We're moving on to dependent events. So, kind of like the last one before, we're going to skip this piece right here. And you can scroll, or not scroll, I'm scrolling. You're just going to move down to this section. We're going to review what independent probability was first. So it is when the outcome of one event does not impact the outcome of the second event. They're called independent. And we said that the probability, you take it and you multiply it times the probability of A and B. So that really meant the probability of A times the probability of B. So that's what we just did. So I know that's gigantic, but just copy it on those blanks. So dependent is different. And if you think about what independent and dependent means it depends on something else before it can mean anything. So when the outcome of one event impacts the outcome of another, it is dependent. So how this is different is you're going to take the probability of A and you're going to multiply it times the probability of B after A occurs. So you're going to see how this works in just a second. Just make sure you have this copied down. If you need to pause, make sure you pause because I'm going to clear it. I'm going to move everything up a little bit. All right. So we're going to read the situations and we're going to describe whether or not they're independent or dependent. So when we were doing independent, remember that if it was marbles, we were putting the marble back in the bag. So nothing changed as far as the quantity. Dependent is the opposite of that. The quantity is going to change. So it's kind of like if you took a marble out of the bag and didn't put it back in. So we're going to go through each one of these so you can understand how that works. So flipping two coins results in one landing on heads and one landing on tails. This is an independent event because no matter what, it's not that you can't take one of the sides of the coin off. It's always going to have two sides no matter what. So we're calling this an independent event. So just write IND. The next situation, Anita reaches into a drawer with necklaces and selects two to wear. So she's got her drawer. She takes one out. She doesn't put it back in and then selects another one. She then selects the second one. So for example, say she had 5 necklaces in the drawer. She's going to choose one out of 5 and she's going to go put that to the side. Now there's 4 left. Her second option would be 1 out of 4 because she didn't put the other one back to retry again. So that second choosing of the necklace depended on what she did the first time. So we're going to call that the dependent. It's a dependent trial. The next one, you draw a joker from a deck of cards and then you draw an ace. So you've got 54 cards because the jokers make it. There's 2 jokers in the deck. So I draw a joker. I don't put it back. So I'm left with 53 cards and then I draw an ace. So this one says nothing about replacing it. So now I have less to choose from. So the chance of me drawing an ace depended on what happened the first time. So we're calling that one dependent. Now let's look at the difference here. This next one, you draw a queen from a deck of cards. You replace it and then draw a 10. So you started with the full deck of cards, you picked one, you stuck it back in, so you still have a full deck of cards. So this one is independent. It doesn't matter what happened the first time around. So we're calling that independent. And the second one, a 3-digit password can be any combination of numbers. Okay, so if you're thinking of, say you're putting a passcode on your phone and you pick a number, is that number gone and you can't choose it for the second number? No, you can still choose it for the second number. So that one is not dependent. We call that independent. So hopefully you can kind of see the difference between independent and dependent. The dependent depends on what happens in the first trial. All right, let's kind of apply this now so you can see the difference. Now, before, our denominators were always the same for the independent trials. You're going to see how this is different for dependent trials. So Neil goes to the pet shop and selects a treat for his dog. He chooses one and then chooses another. So what's the probability that Neil selects a bone and then a ball? So think about this: if you go to the store and you got a whole bunch of treats on the wall or whatever, you pick one off and now there's one less up there. Then are you going to put that back and then choose it again? No, you're just choosing from one less. So that's why this is independent. So I've got 7 options up there, and I want to know the probability of choosing a bone and then a ball. So I have 3 bones out of 7. All right. So I reached in, I took one out. I'm for sure left with 6. So I know that on my second choice, I'm only going to have 6 options, and I have 1, 2 to choose from. So now I'm going to do the same thing as I did before as in multiply. So 3 times 2 is 6, and 7 times 6 is 42. This is going to simplify to 1 out of 7. So you have a 1 out of 7 chance for this dependent event of selecting a bone and then a ball. All right, let's try the next one together. I'll clear. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? P.S. If you hear that dog crying in the background, it is not my dog. It's the neighbor's dog. And it breaks my heart. But anyway, let's go back to this. All right. So I have 5 candles in total. So I'm going to start with my 5 here. And I want to know polka dot. 1 polka dot, 2 polka dots. So we've got a 2 out of 5 chance. So 1 is taken away. We're not replacing it. So I'm left with 4 times something over 4. If I took a polka dotted one out on the first trial, I only have 1 polka dotted one left. So I can only choose 1 there. Now I'm going to go ahead and multiply. 2 times 2 is 2. 5 times 4 is 20. And that simplifies to 1 to 10. So because we're looking for the same thing both times, and if I took it out the first time, I got to make sure I've subtracted it from the top as well as the bottom. Now that's different from the problem before because they were 2 different objects. So the first time I picked a bone, it didn't affect how many of the balls were left in there. So that's why we had to complete it this way. All right. We're going to do a couple more together. So let me clear this. Go back to my mouse. Move this. Whoops, not that. Oi, oi, oi. Move that. Go here. I know you guys like when I'm operating things here, trying to figure it out, right? Okay. Let's take a look at number 4. I don't know. Can you hear that puppy in the background? It's so sad. Anyway, okay. Mrs. Moore is doing laundry and has various pieces of clothing in her laundry basket. So that's a picture of all the clothes she has. What's the probability of selecting a top and then selecting a bottom? All right. So first thing we got to do is figure out how much we have all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got 16 in total. Okay, I need a top. So my tops are 1. 1 top. 1 out of 16. Okay, we're not putting that top back, correct? So we know we're left with 15. And then a bottom. 1, 2, 3, 4, 5 bottoms. Okay, I'm going to pause, so make sure you get that down. Now we're going to go ahead and just multiply. So 5 times 1 is 5. And 16 times 15 is 240. Now I need to simplify. 5 divided by 5 is 1, and I'm using that because the 240 ends in a 0, so I know I can divide by 5. And 240 divided by 5 is 48. So there is a 1 in 48 chance of picking a top and then a bottom. So that was a dependent event because what I did for the second pick depended on what happened on the first pick. So what is the probability of selecting a striped sock, replacing it, and then selecting another striped sock? So because I'm replacing it, I know this is independent, which is not going to change my denominators. So I'm going to keep them both at 16. So I need a striped sock first. 1, 2, 3, 4, 5. I see 5 out of 16, and then selecting another striped sock. So 5 out of 16. So I'm going to multiply that together. I get 25. I'm writing it over here because I'm running out of space. And then out of 16 times 16 is 256. Now, the only thing that's going to divide into 25 is 5, and I know that that's not going to work with the 256. So this is simplest form, and this is an independent. Make sure you know that that's independent. Here is your job. I'm going to scroll here. You are going to complete C, D, and E on your own, and then also complete number 5. Once you're finished, please come and check with me. And again, we will go through. You're going to complete your mastery check and your homework page. Then, if you have time, there is a independent con that you can do.